So next, we have streak. So I mentioned this a while ago. So streak is the color of a mineral in powdered form. So the color of a mineral could be different from the streak. Example, pyrite exhibits golden color, hence the other term for pyrite is fool's gold, but it has a black or dark gray streak. So if you're going to scratch it on a hard surface, for example, uh, that the thing that they use for scratch test, so it will exhibit a black or dark gray color. Okay, so it has a dark gray or black streak. So streak is a better diagnostic property as compared to color. So if you're going to choose between streak or color, streak is better. So streak is useful for identifying minerals with metallic or earthy luster. So streak is obtained by scratching the mineral on an unpolished piece of white porcelain called a streak plate. So this is an example of a streak plate. So we can see here the color of the hematite and magnetite. So hematite being reddish in color and then magnetite grayish. So when the mineral is rubbed across the plate, it produces a powder of that mineral, the reason that the streak plate is harder than most minerals. So when the excess powder is blown away, what remains is the true color of the mineral. So you cannot rely on the color itself. So just like the pyrite, so it is somewhat similar in gold in color, but the streak is similar to this one, magnetite. So streaking reveals the internal color of the mineral, thus it is more reliable than color in identifying minerals. So this is the reason why it's better than color. Okay, moving, we have crystal form or habit. So this is an external shape of a crystal or group of crystals that is displayed or as observed as crystals grow in open spaces. So it reflects the supposedly internal structure of atoms and ions of the crystal or the mineral, the natural shape of the mineral before the development of any cleavage or fracture. So crystal forms can be, examples can be prismatic, can be tabular, bladed, or we have this one here. So crystals, isometric, it can be tabular or lamellar, acicular, columnar, cubic, prismatic, amorphous, or octahedron in form. So these are the crystals. So the following minerals are both made of pure carbon, so graphite and diamond, but they are different due to the arrangement of the atoms. Okay, so graphite is actually arranged this way in sheets. Okay, so if you notice, it's like a piled sheets of paper. While diamond is arranged in lattice or crystal lattice. So there's a definite chemical there's an internal arrangement of atoms. So that's for crystal habit. So again, we have the different crystal forms or habit. We have octahedron. Examples of this are fluorite, pyrite, and diamond. Cube being table salt or the halides. Then we have complex, we have twinned or prismatic or prism, like the tourmaline or quartz. So a mineral that does not have a crystal structure is described as amorphous. So an example of an amorphous is this one here. Okay, that is amorphous. Okay, next, cleavage. So cleavage is the property of some minerals to break along parallel repetitive planes of weakness to form smooth or flat surfaces. So when the crystals are formed, they uh, they are piled on, or they are grouped together, and the weakness or the plane where they are on their weakest point or the weakest part is actually the cleavage. So these planes of weakness are parallel to the atomic planes and appear to be repeating within the mineral. So the tendency of a mineral to break evenly along its weakest plane. So examples of cleavage, you have basal, prismatic, non-prismatic, cubic, rhombohedral, octahedral, and dodecahedral. So example like halides or the salt. Okay, this is an example of a cleavage. So this is the crystal habit or the crystal form or the habit. So the weakest part, if you are going to have another, say it's cubic in form, or the crystal is cubic. So cubes are piled on top of the other or beside each other. So like that. So the weakest part or the plane of weakness between them is actually the cleavage. Okay, for fluorite, it has this shape. It has octahedral, or it has 8 faces. And then calcite, okay, it's like cubic or slanting, or non-prismatic or rhombohedral. Okay, so that's the cleavage. So if this part here is going to break, so the tendency, if it's halite, then the habit or the crystals that will be formed are cubic in nature or cubic in shape. So cleavage, when minerals break evenly in more than one direction, cleavage is described by the number of cleavage directions and the angles between planes, or cleavage in two directions at 90 degrees to each other. So we can have the different uh, types of cleavage here. So muscovite is in sheet form in one direction. Two directions, we have feldspar. And then we have 3 directions. So this one here, I hope you can see that. Okay, okay, the cube there. That plane of weakness, this one here, is actually the cleavage. So it will form a cubic or a cube type of crystals. And then similar to that one, still 2 directions is, but it is slanted, is example of that is calcite. Okay, so cleavage versus crystal habit. Although both are dictated by crystal structure, crystal habit forms as the mineral is growing, therefore relies on how the individual atoms in the crystal come together, while cleavage, on the other hand, is the weak plane. So I have discussed or talked about this one, that plane of weakness is the cleavage. Okay, that cubes piled on top of one another, or they are grouped together or lying side by side, is actually the crystal. Individually, this is the habit or crystal form. The plane of weakness is the cleavage. So I hope you understand now the difference between the two. Okay, so example, you have here a quartz crystal habit. So this one is an example of a prismatic crystal form. Okay, For fluorite cleavage, this is the crystal, but then the plane of weakness, or where they are joined together, and the weakest part, when you break that one, that's the cleavage. But this is actually the whole thing here is the crystal. That plane of, okay, this one here, where they are its, or on their weak part, is actually the cleavage. Next, we have fracture. Some minerals may not have cleavages but exhibit broken surfaces that are irregular and non-planar. So quartz, for example, has an inherent weakness in the crystal structure that is not planar. So examples of fracture are conchoidal, fibrous, hackly, and uneven, among others. So example of this is this one. So asbestos, instead of having a cleavage, it has fracture. So it has, it's uneven, not even in. So if crystals break, they don't have a specific direction. Okay, so they will not exhibit, or they will not form a, what's this, a shape. Okay, a fixed shape. So it's fibrous in nature, or the fracture is fibrous. It's like fiber or grain or strands of hair. Conchoidal, okay, example quartz, the conchoidal fracture, it's like a chipped glass or a broken glass. Okay, so you can see the ripples of, what's this, the where the where it is weakest. Okay, so that's the fracture. So here I have different minerals, and you are going to help me identify whether it exhibits cleavage or fracture. So we have number one. Okay, so actually number one is an example, or it exhibits cleavage. Okay, so it has a definite shape. Okay, this can be two direction, or yeah, two direction or three direction. So that's an example of a cleavage. Number two, we have fracture. So you can see here it has no definite crystal. Okay, the planes of, or the plane of weakness here, it's conchoidal fracture. So number three, okay, yes, you're correct. That's fracture. And number four is cleavage. How about number five and six? If your answer number five is cleavage, then you're correct. And then for number six, it's fracture. So I guess you know the difference now between cleavage and fracture. Next, we go to specific gravity. Okay, the ratio of the weight of a mineral to the weight of an equal volume of water is what we call as specific gravity. So a bucket of silver with an SG of 10 would weigh 10 times more than a bucket of water. So which has a specific gravity of 1. So it is a measure to express the density or the mass per unit volume of a mineral. So specific gravity of a mineral is numerically equal to density. So that's for specific gravity. So minerals they can have a specific or a fixed let's say specific gravity, but of course they're going to look at they are going to compare it to the specific gravity of water. So meaning if it has a specific gravity of, for SG 15, so meaning it weighs 15 times than the water. Okay, so that's what we meant by specific gravity.